does it explode? Should I be afraid? Almost every Brazilian kitchen has a pressure cooker, and while it's super useful, it's also something many people are afraid of. There are more than 1,200 pressure cooker accidents in Brazil every year. Some people don't even go near them. If you're one of those people, stick around until the end, because today we're going to clear up all the doubts about pressure cookers. How do pressure cookers work? Why do they work? And do they really cook faster? And how do you make sure the thing doesn't explode? In Brazil, we use pressure cookers a lot, and it makes perfect sense because we eat a lot of beans, and everyone knows that beans cook much faster. What? Not everyone knows about pressure cookers is why they cook faster and better. The pressure cooker was invented about 300 years ago by a French physicist named Denis Papin, who, in English, we can just call Denis. Really, this guy. Denis invented the pot in 1670, but Brazil was still a colony of Portugal, and it was more than 50 years before Tiradentes was born. At that time, things were lit with candles, with oil lamps, and pretty much everything was handmade. The Industrial Revolution, which was when people started using machines, would only happen more than 100 years later. And here's a spoiler, the pressure cooker has everything to do with this revolution. The first pressure cooker was made of cast iron. Cast iron is when you have to melt the iron and then put it into a mold. Just so you have an idea, this here is made of cast iron. It doesn't have a fancy finish or anything like that, but it's still very strong. That's because at the time it was invented, we still didn't have a way to properly work with aluminum, steel, stainless steel, those more refined metals that we use today. The first version you see on the side was bulky, but it already included a spot underneath for lighting a fire. And it was called Papin's digester, or bone digester, because the main goal wasn't exactly to cook with it. The idea was to take animal bones, left over at a slaughterhouse, after you killed the animal and removed the meat, and you had a carcass left. You would cook that and use it to make fertilizer and gelatin. Yes, gelatin comes from animals. If you had never thought about that until then, if you were going to cook something, you would simply grab a pot, put water in it, and put it on the stove. Some steam would come out, but that was just a side effect of cooking. Papin, or Denis Papin, trying to hold in that steam. Hey, what if we completely closed the pot? Would that make a difference? Then he did the test, trapped the steam, and realized that the water got much hotter than usual. And because of that, when he put something inside, the food cooked faster and became softer. The intention was to soften bones, but Papin realized that this pot could be used for anything, and then he started doing demonstrations of his pressure cooker, cooking all sorts of things. The things he cooked back then were pretty strange. For example, pigeon made a good dish, even though it was very efficient. Papin's pressure cooker wasn't very successful at the time. People thought it was strange to eat something that had been made in this more scientific, more technological way. Yeah, kind of like how a lot of people feel about microwaves these days. But hold on. Papin was a great scientist, and he noticed a very important detail in that clunky pressure cooker of his. If you look at the pot, you'll notice it has a kind of little handle with a weight at the end. That's the valve. Imagine there's a hole in the pot, and the valve covers it. This hole here at the tip has a weight that you can place closer to or farther from the hole. And this determines how strong or weak the valve will be, how much you want it to hold the pressure or not. And Papin noticed that this valve, as the steam built up pressure, would start moving. It would make a motion. And then he designed a system that put a piston there and managed to create movement from the steam without even knowing it. He was creating the prototype of the world's first steam engine. And it was the steam engine that caused the entire industrial revolution at the beginning of the 1800s. So, can we say that it was the pressure cooker that inspired the first steam engines? Yes, the pressure cooker came before the steam engine. But Papin died in 1713, poor guy. His inventions were never actually used in practice, so he didn't see the popularization of the pressure cooker, much less the steam engine. But anyway, what exactly is pressure cooking? What difference does it make? When we take a regular pot, like this one here, you put water inside the pot, put something in to cook, and cover it with a regular lid like this. The water starts to boil and it reaches at most 100 degrees Celsius. That's because, under normal conditions, more or less at sea level, water boils at 100 degrees Celsius. So, the water starts to heat up. If it wants to go beyond that temperature, it turns into water vapor and goes away. So it's practically impossible for you to get a regular pot to reach more than 100 degrees Celsius with water inside. That's not the case with the pressure cooker, this pot. When the water starts to boil, it traps the steam inside, and the steam creates a lot of pressure. The steam pushes hard trying to get out. And then there's a very interesting phenomenon that happens, which is this water boils in this pot at 100 degrees Celsius at atmospheric pressure, at ambient pressure. But when you have more pressure, it's as if the weight of that air, the force that the air is putting on top of the water, doesn't let the water evaporate. That means that under higher pressure, water needs a higher temperature to evaporate. So inside this pot, it doesn't evaporate at 100 degrees C. It will evaporate at around 120 degrees C. 20 degrees Celsius more than in this pot, and that makes a big difference. First, things here will cook faster because you trap all the heat inside and cook at a higher temperature. Second, there are some things. If you only heat it to 100 degrees 6, like some meat fibers or some grains, they won't cook very well, but in here, they'll get much softer. So, this temperature also makes things softer. It's not just about cooking time, it's also about temperature. So, in the end, the pressure cooker cooks better and faster simply because it gets hotter. And of course, for all this to happen, there's a whole engineering process here, which I think is amazing because it's so simple. Everyone has one at home, but we rarely stop to think about it. First, we have a lid. That's oval, not round. And that's because we need to close the pressure cooker from the inside. See how cool this is? A rubber seal here keeps the pressure from escaping. It seals the pot really well. And if we try to put the lid on in the closed position, it won't fit. You have to turn it 90 degrees here. It fits. That's why it has this oval shape. And then you can lock the pot. You can notice that this little flap, this gasket, stayed on the inside. And this is very important because when the steam starts to push, it will try to open this lid. It will put pressure on the lid, but this little flap will get even tighter. The pressure will help the pot close by itself. When you close the pot, this handle will form a kind of lever here. So, when you press it, it tends to pull the lid off, but it won't come off. For the same reason I already mentioned, there's that ring with the gasket inside. So this works like a kind of spring that you lock here in this safety latch. So this way, the pot stays extremely well sealed. And of course, this spring and the little latch are also a guarantee that this lid won't open at the wrong time. That as long as this is closed, everything is fine. But okay, I closed the pot, put it on to cook. Where is this steam going to come out? But I remembered, what a silly question, right? Of course, it's going to come out through the valve because everyone sees the steam coming out through the valve. There's nothing obvious in this world. My dear, yes, the steam comes out here. There's a tiny little hole right up here, which is for the steam to come out. The question is, why do we use this weight on top of this hole? But that's obvious. It's because it looks nice. It makes a little noise while it's cooking. Oh my goodness, that's pretty much it. First of all, this little thing here is quite heavy, and that's on purpose. It weighs 58 grams. This weight is precisely to make it harder for the steam to escape. It acts as a kind of regulator for how much pressure you want to build up inside the pot. Because for the steam to escape from here, it needs to have enough force to lift this valve and open the vent. So, the heavier the valve is, the harder it will be for the steam to escape. It already has the exact weight to keep it at the right pressure. And yes, it would be possible to make a valve that doesn't make noise, that doesn't move, but this movement, this dance of the valve, it's there to alert whoever is cooking that the pressure cooker has reached its maximum pressure level. This is important in the kitchen, because many times you measure the cooking time. From that moment on, from the moment the cooker releases pressure, from the moment steam starts coming out of here. And this thing spins, but there's also a safety mechanism here. If this thing stops spinning, it's an emergency, and we'll understand more about that later on. This isn't the only valve on the pressure cooker. Just like you have 2 nostrils and a mouth to breathe, there are several backups so you don't suffocate. And the pressure cooker also has other backups. If this valve gets clogged, because it can get clogged depending on the food you put inside, there's another valve. In this case, on this cooker, it's made of rubber. There are other cookers where the valve is located here under the handle, and the idea of this valve is for it to burst, to break open when the pressure gets too high. In this case, it also serves as a pressure indicator. When there's pressure inside the cooker, this little black pin rises, and you can see that some force is being exerted from the inside out. In this brand of cooker that I have here, there's still another safety device, which are these two little grooves on the sides. Let's suppose both valves don't work. Both get clogged for some reason, and the cooker is about to explode. Instead of exploding, what will happen is that the little rubber ring of the cooker that you can see here inside the curve, it will come loose and release the pressure. And one last thing about this cooker is that its body is usually much more resistant than a regular pot. So, if you look at the thickness of the aluminum, the rigidity, etc., it's much greater than an equivalent pot. Enough talk. Shall we cook something in this cooker? What I used to love doing as a kid was cooking condensed milk in the pressure cooker. And yes, that's a dangerous thing to do, but it works really well. The first question that might come up is whether we can cook a can if the can won't release any toxic substances into the food or anything like that. When I was a kid, not only did we cook the can, but we also cooked the can inside the beans. I don't think that's very cool anymore, because there's a glue here that used to hold the label on the can, and that glue ends up dissolving into the beans. I'm not sure if this glue is safe to cook, but since the can is fine, I'll just cook the can by itself then. And here comes the most important thing of all, which is how much water you can put in there. The rule is that we first put the food in, and then add the water, because the water can go up to, at most, 2/3 of the pot. And this is the most important thing of all, so you don't blow up a pressure cooker. The problem is that if you put in some food, it creates foam, it creates some substance that turns into a porridge, and you fill the pot almost to the top. That food, that mush that's going to form inside, it's going to clog the valve. It's going to try to come out through the tiny hole in the valve, and it's going to get stuck. That's what causes most of the problems with pressure cookers. Depending on the consistency of all that mush, it can block all the outlets. And then, yes, a pressure cooker explosion can happen, which is very serious. The steam creates an absurd amount of pressure. What can happen is the pot can spit out the lid, and even then, it's unlikely you'll have your head right above the lid. But what happens is that extremely hot water will fly everywhere, along with all the mess that was inside, splattering all over the place. If you look at a photo of a pressure cooker explosion, you'll see that usually the stove even gets pushed down. The impact is so strong that the stove sinks, and the entire kitchen gets washed with extremely hot liquid. That's the worst case scenario. If that doesn't happen, the valve might come off, or suddenly pressure could leak through the gasket, which is another problem. If the gasket isn't in good condition, if it's torn or about to burst, it could fail. It could be that at the peak pressure of the pot, the gasket comes off, it tears, it lets something leak, and you might get a blast of hot gunk in your face. So a second thing to ensure the safety of the pot is to always take a look at the gasket to see if it doesn't have any issues. And one last thing is this valve. Over time, it can start accumulating dirt and get tighter and tighter, and then the chance of it getting clogged increases. So it's always good to hold it up to the light to check if everything is clear and blow through it. Check if the air is passing through well, to make sure the valve is working. To be honest with you, this pot is bigger than it should be for me to cook the 2 cans. But the other one I want to do a second experiment with it, which I'll do in a little while. I left it on high heat, waiting for it to build up pressure. Let's wait for the valve on top to start spinning. And now, how much dulce de leche is in there? Let's prepare a comparison between the 2 pots. I cook beans in a regular pot and in a pressure cooker, so we can see what the real difference is, if there's really that much of a difference. And I'm going to use exactly the same amount of beans, the same amount of water, and pots with a very similar bottom area. And I'm going to put them on the same burner of the stove, on 2 identical burners of the stove. These beans have already been soaked in water from yesterday to today. There's a kilo of beans here. Just so you have an idea, it was a bag this size. The beans, since they absorbed water, swelled up a lot, and the volume kind of doubled. I'm going to see how much fits more or less in the pot, and we'll see how much that is in grams. Down here, half a kilo of beans. Now I'm going to add water until it's two fingers above the beans. That's 900 grams of water, same thing in the other pot. Here, theoretically, I should actually add more. It takes much longer to cook, and the water evaporates more. So it actually needs more water than the other beans. At first, I added exactly the same amount. Since the pot is a little narrower, it ended up being taller. Let's start cooking. I'm using two identical burners here, and I'll turn on both pots at the same time. The valve started spinning, which means it's pressurized. From now on, we start timing the dulce de leche. 40 minutes, and the fact that the valve is spinning is very good. That's important. That has to happen. If you leave the pot here, I don't know, for 20 minutes, half an hour, and the valve doesn't spin, you notice that the pot is hot, but the valve isn't spinning. Turn it off. That's a very serious problem because it means the water is heating up. It's generating steam inside, but it's not able to escape. The valve is probably clogged, so the fact that the valve is spinning means everything is fine. Everything is okay, you're safe. Another thing you can do at this moment is to put the pot on low heat, because if the water has already evaporated, it's already reached the right pressure, it's already at the maximum temperature. You don't need to keep turning up the heat. Just a little bit of energy is enough for the water to stay at the maximum temperature. When it's boiling, this also applies to a regular pot, not just a pressure cooker. There's no point in adding more heat once it's already boiling. When water is boiling, it can't go above 100 degrees unless it's in a pressure cooker. And in a pressure cooker, it can't go above 120 degrees. No matter how much more heat you add now, this valve is also like a little steam engine. It's turning the chemical energy from the fire into kinetic energy, into movement. How does that happen? Is there some special design? Music. If we cut that valve open, we'd find some ducts, more or less. So the steam escapes from the pot through the center, and it needs to get out. The exits it will find are these four here. So the steam escapes through here, here, and here. If you look closely, these exits are not aligned with the center. They don't reach the center. They're offset. This offset will make the valve spin in this direction. I point in the opposite direction here, right? It's going to spin this way. It's going to spin like this. The logic here is pretty much the same as the Heron engine we made with Professor Augusto last year. The steam comes out kind of sideways and makes the whole assembly turn. Both pots started to boil, so I'm going to lower the heat on both, especially because they start to release some foam. You can see here. Looked at the beans. Even though they're a cleaner grain, they still release some gunk. Actually, a little bit leaked down here when it started to boil, theoretically. But after 20 minutes, this one is ready. Here I'll have to leave a little gap in the lid. Otherwise, this foam will start trying to come out of the pot. A cool thing that happened is that the pressure indicator, which is on the second valve, went up. You can notice that it's a little bit up. Everything here is at the maximum temperature it can reach. And let's try to measure with the thermal camera to see if there's really any temperature difference between the pressure cookers and the regular pot. I had to stick some tape here on the pressure cooker because you can even see on the thermal camera that aluminum reflects infrared, which is what this camera is measuring. So you can't really measure the temperature of aluminum properly. By using a thermal camera with tape on top, we can measure the regular pot at 90 degrees Celsius. The water boils inside, but the pot's exterior likely stays cooler since it exchanges heat with the environment. Besides that, we're in a high altitude area in Sao Paulo, and here the water boils at about 97 or 98 degrees Celsius. On the other hand, the pressure cooker reaches 109, 110, 111 degrees Celsius. Much higher, and down at the bottom, it's 107, 108 degrees Celsius. So here we can prove that, in fact, the pressure makes the pot heat up a lot more. That was pretty much what we had predicted, about a 20 degrees Celsius difference. Time's up here. Out of all the pots, 25 minutes under pressure for the beans. I left it a little longer, 45 minutes for the dose delete, and there was this pot that didn't go under pressure. The question now is, can I put this under running water to cool it down faster? The beans. Yes, from everything we've read, there's no problem at all. There's no risk of the aluminum cracking. Nothing like that. You can cool down the pot. This will make the temperature inside drop a lot, and the pressure will also decrease. So, in a little while, we'll be able to open it. The pressure valve has already gone down, which means that, probably, if I open it here, there's no problem, even under pressure. When I release it here, the lid won't open on its own. it won't let you open it. We'll show this with another pot, but don't try it at home. But if I release it here, the lid doesn't open because it has pressure from the inside out. Now, this pot with condensed milk inside, can I open it now? I wouldn't do that. Let's understand what's happening. Inside the pot, when it starts boiling, steam begins to come out. Through here, it means that inside, the water will be around 120 degrees Celsius, both the water outside and the liquid inside the can. None of this evaporates because there's a lot of pressure that the pot is putting on the water. So this pressure doesn't even let the water here evaporate. And it also doesn't let the can explode, because if it's 120 degrees Celsius inside and there's liquid, there's water, what's inside will also want to come out. Also, there will be pressure here from inside the can pushing outward. When you turn off the heat and pour water on top, this pressure drops a lot, and so does the temperature of the water here. So the water, I'd guess it will be around 95 degrees C, more or less. The lid is already open, but the question is, did the can really cool down that much? Could this can, for example, be at 105 degrees Celsius, which is a temperature above the boiling point of water at normal pressure? Is it possible that there's still pressure inside the can, trying to escape because it hasn't completely cooled down? I think there is. So there's a risk if you open the lid of the pot because you release the pressure, and this can could explode. If you open it and it doesn't explode, then you take out the can and you're going to open the can. It might go wrong when you open it because there could still be pressure. Couldn't escape. If you open the can while it's hot, it'll burst. So what's the safest thing I can do here? We keep the pot covered. You can even cool it down with water, but don't open it because then the can will cool down naturally. You should only open the pot when you touch it and it's at room temperature, not hot anymore. Then, for sure, the can has already cooled down. There's no problem opening it then. In total, it was 45 minutes on the stove. Okay, now, let's compare the texture of the two beans to see the difference. You can already notice it here. Let's go to the studio. These are the beans from the pressure cooker, and these are the beans that were cooked in the regular pot, both with exactly the same cooking time. I'm not going to taste it alone, right? Because now we have several people here to be our guinea pigs. Daniel, you can try your beans. I'll take this one first, and then you can tell me about the other one.
Even the color is different, huh? Tasty and very soft. It just needs a bit of seasoning, but it's still really good.
This one's really tender. Try it yourself.
I think I was tricked.
It's tough and raw. I think he overcooked it a bit. This pressure cooker could have been taken off 5 minutes earlier.
It's really soft, actually.
It even cracked a bit with the beans, but this other one is fine.
The only reason this one isn't worse is that it's soaked for a long time, so the bean itself was already soft, even raw, but still, this one is far from being cooked. Yeah.
No, the pressure cooker cooks much faster. The pot lost pressure, but it's better not to open it, right? Before I open it, tell me what you did. No.
I went to check the instructions for the experiment, right? And I opened the pot. Here's the thing, when the pot cools down, the lid goes down, right? Because of the loss of pressure. But I didn't realize that there was...
This latch needs to be loose so the lid can close.
It was already loose when I checked, so I didn't touch it. I just went to look at the experiment instructions, right? I went to see if the pot was cold. Since it was cold on the outside, I put my hand in to see if it was cold inside, and it was already cold. So I didn't do anything irresponsible. I was just analyzing the experiment.
You probably won't believe it, but it happened to a friend of mine, who maybe you guys know. You see.
My accident happened because I had an uncontrollable craving for dusty light. But it was during the pandemic. There was no vaccine yet. And I couldn't just leave the house and buy Dust Elite at the supermarket. So what did I do? I remembered that I had a can of condensed milk in the pantry. Everyone knows that if you cook condensed milk, eventually it turns into Dulce de Lake. It caramelizes and becomes Dulce de Lake. I did it, but my craving for something sweet was so strong that I didn't give it enough time. First, I didn't give the condensed milk enough time to cook and harden inside the can. And I also didn't let it cool down inside the can after I turned off the pressure cooker. And when I opened it, I have a vivid image of that hot condensed milk. It spurted out, falling on my head and running down my face. And a lot of it ended up on my eyelid. It was bad. Is there a video on Kada Chave telling this story? I'm wearing an eye patch, and actually I messed up the timing. I should have waited for the temperature to go down. Don't do this, don't repeat my mistake. I must admit the dessert was great since we finished the leftovers.
Thank you for sharing your story. I think now some people here have been convinced.
Now I'm convinced.
Just for the record, look, the danger, the bulge in the can, the way it is here. Clearly, some dulce de leche tried to escape through here. Look at the seam of the can here. Exactly like it is in the drawing. I think this is good, honestly. You can open it.
May I have the honor? The color looks good, huh? Let's see. Turned out good, huh? Better than raw beans?
Wow. Way better than the beans.
I know Jansen also grabbed a spoon. Are you ready to try it here?
Jansen came from the kitchen. We waited here for him, but he didn't show. He just went to get a spoon for himself. Jansen. Look at the size of the spoon they want me to use.
Well, man, you're gonna have to eat the whole spoon.
My conclusion. If you're afraid of pressure cookers, you're not completely wrong. 1,200 accidents per year. It's no joke, but let's agree that after watching this video, you understand exactly how it works. You know what precautions you need to take for the pressure cooker so it doesn't explode and no accidents happen. Pay attention and don't forget to share this video with anyone you think might be doing things that could cause an explosion pressure cooker.